morning. We are at the Smithsonian's National Air and Space Museum, and we're here today to talk about exploration. I'm Valerie Neal. I'm the chair of our Space History Department, and I welcome you here. You know, human beings have always been explorers. They've always wondered what's beyond the mountains, what's across the sea. They've gone looking for more water, more land, natural resources, a new life, more space. And that's exactly what we're doing today with space exploration. We are fortunate today to have a special guest with us, Astronaut Jon McBride, who has been a naval aviator, a combat pilot, a test pilot, an aeronautical engineer, and an astronaut on the space shuttle. And he now works at Kennedy Space Center in Florida, where he's helping plan the next stages of exploration. He's here to meet with us today in the museum and also to speak to our guest on Facebook Live. Welcome, Captain McBride.
John is fine. Thank you, Valerie. Thank you. Welcome to the National Air and Space Museum, one of my favorite places on this entire planet. I think total over the last 40 or 50 years, I've probably spent 1,000 hours inside this one building. So you can't see and do it all. I'll guarantee you every time you come back, you're going to see something new and different. So it's a very special place. And we're very happy to be here with our Mars Rover. We built this down in Florida at the Kennedy Space Center by the Parker brothers at Cape Canaveral, as a matter of fact. And from the time we set down less than a year ago, you see what we've got here. It's a magnificent machine. This thing you see behind me is not going to be the one that actually goes to Mars, obviously. It's going to have to be much more complex and built out of different materials and probably a lot lighter than you see here. This is built to be transported around on Earth to show you what we think the Martian vehicle is going to look like. So we took the best of our knowledge that we currently have, talked to all the people that are designing the rovers for Mars, and this is what we came up with to bring out to the public to encourage you to support the space program. And more importantly, I love to talk to the youngsters around the audience, and I've met several hundred of you this morning, and I love to see the twinkle in your eyes when we talk about Mars and the fact that you, I'm looking at you right now, you too can become an astronaut, and you could be that first man or woman that walks on Mars. We think that person today is somewhere between 6 and 18 years old. So there's a lot of you here between 6 and 18 years old. If that's something you want to do, this is the first day of your rest of your life to think about it. And you're the one that can make it happen. And the most important thing you need to do is study. Listen to your moms and dads and your parents and your teachers and old astronauts like me when we tell you that it's important that you stay in school, do your homework each and every day, listen to your parents and your grandparents, your teachers and your counselors, the people that love you the most. And if you're willing to do that, there's no reason in this world why you can't come down to Houston and join the class of astronauts that will fly off to Mars and rove the Martian surface with this vehicle behind me. I can't think of anything much happier than to think that I got to talk to you this morning. If you get that assignment to Mars, make sure you call me. NASA will find me somewhere. I hope to still be around. And make sure you invite me to your launch, because I want to come down and see this thing left off with the crew to go off to Mars. It's going to be about a year for you to get there. You know, Mars and Earth aren't very close normally. The closest we ever get to Mars is almost 50 million miles. So it's going to take a year to get there when we're at the closest point. And lots of times we're on opposite sides of the sun, billions of miles away from one another. So you wouldn't want to take off and head to Mars when you have to fly through the sun, would you? That's not a very good idea. So we're going to take off and fly to Mars when we're nearest approach, which is about 50 million miles. So we get there in about a year. It's going to take you a year to get there. And you don't want to just go over and spend the day, right? You're probably going to spend another year or two on the surface of Mars before you can return to Earth. So we're talking a 3 to 4 year voyage for those first folks that lift off with this vehicle and head to our sister planet called Mars. And I certainly hope I'm around to see it. If you've got connections up here on the Hill, the Capitol Hill with your senators and congressmen, call them, write them, tell them we need to get this thing going, get this We Americans need a vision. We need a challenge, much like we had back in 1961 with a gentleman by the name of John F. Kennedy. I'm a very lucky man. I got to meet him when he was campaigning, and I came from a little home state called West Virginia, right next door. Came through my hometown campaigning, and I read in the paper he was going to be in my hometown courthouse that afternoon at 4 o'clock. I got out at 3:45 and ran across town. Small town, only 2 minutes, and got there about 10 minutes before anybody else did. Got to spend maybe 10 minutes with John and Jackie Kennedy and their aides. It was a real inspiration for me because I was already into rockets and airplanes and science and all those kind of things. And a year later, in May of 1961, when he said, we're going to go to the moon, that grabbed me. That got my attention. It got the attention of each and every American in those days because we all were then unified together as a country to make that dream come true. He also challenged us to do it by the end of that decade. So he meant we wanted to be on the moon before 1970. And we did it. All the wonderful people at NASA and all the scientists in this country formulated a plan and allowed us to land on the moon in July of 1969. So we fulfilled President Kennedy's challenge. And I think it's sort of the kind of thing we need here in America today to go do something big and grand and grandiose by sending our first American citizens to the surface of Mars. So I would love to see that happen. Got to get it going pretty soon. So I was very fortunate. I was idle. I idolized the Mercury and the Gemini and the Apollo guys, and little did I know that a little later in my life I would get to know all of them. I was very fortunate to have been chosen in the very first class of space shuttle astronauts. So everybody that came before me were those Mercury and Gemini and Apollo guys that I had idolized. So by being in that first class of space shuttle astronauts, I got to know all of them. As part of our training process as new astronauts, all the Mercury, Gemini, and Apollo folks would come to our classroom in Houston and debrief us on their particular mission, the results, the problems they had, the failures. And by the time that we'd listen to all the Mercury, Gemini, and Apollo guys relate their mission objectives and all the problems they had and the successes, we were pretty familiar with just about every aspect of flying in space, except none of us had ever done it before. And it took about 3 or 4 years for us to get our initial training at NASA before the first class of space shuttle astronauts were trained and ready to go fly in space. There were 35 of us in that first class of space shuttle astronauts because we needed a lot of people to man the space shuttle. We were going to fly as many as 7 people per flight and as many as 2 flights per month. So you can see you needed a lot of people. We had 15 of us like myself who were pilots, the traditional test pilot, combat pilot kind of person. The other 20 in my class were a new category of astronauts called mission specialists, which included Sally Ride and our first 6 American women. It included Guy Bluford and our first African Americans. It included Ellison Onizuka, Japanese Hawaiian, first mountaineer from West Virginia. So it really was a unique, unique group of folks that manned up that first class of space shuttle astronauts. And each and every one of us got to fly at least one flight into space. So I guess you could say NASA was very successful in that recruitment process and the training process for that initial class of space shuttle astronauts. So been around for quite a while. That first flight we flew was 9 days in duration. For you youngsters, I don't know if you realize it, but when you're in space, in the space shuttle and other spacecraft, we go around the Earth every 90 minutes, every hour and a half. We circle the complete globe. That's about 24,000 miles in an hour and a half, so it's about 17,000 miles per hour. We're traveling over the Earth at about 6 or 7 miles every time my heart beats. So we now have, since I started counting, we've been from Washington down to Richmond. So that's how fast we travel in space. It's about 6 or 7 miles per second. Across the Atlantic in about 12 minutes. So you put all these things together, the thrill of the launch from 0 miles per hour to almost 18,000 miles an hour in 8.5 minutes. And then when the engine shut off, you're going around the Earth at almost 18,000 miles an hour. The beauty of Earth is gorgeous. One of the things that happens, by the way, when you go around the Earth every hour and a half is that half the time you're between the sun and the Earth. So you have sunshine, right? When you go behind the Earth, you have a sunset. And then you're in darkness for 45 minutes. And then I have another sunrise, 45 minutes of daylight and a sunset. And it repeats itself 16 times a day as I circle the Earth 16 times every 24 hours. So I get to see 16 sunsets and 16 sunrises each day, each and every day in space. And they're not like here on Earth. When you sit out on the beach there at Virginia Beach and watch the sun come up, it's maybe a 9 or 10 minute evolution to get a total sunrise. Since we're traveling at the edge of the Earth at almost 18,000 miles an hour, the sun rises in about 10 seconds overhead for 45 and a 10-second sunset behind you. So for you youngsters, when you put all these things together, the thrill of the launch, the excitement of being in orbit, but most importantly, doing some great science. We don't go up there just to play. We go up there to conduct research, launch satellites, study the Earth, study our universe. So when you put all these things together, it's the #1 job in the world. And that's why it excites me to see you youngsters out here at the Air and Space Museum, looking at the futuristic rover of Mars. See the excitement in your eyes, which I love. And once again, I hope that I'll get that invitation to your launch one of these days when you're the first man or woman that lifts off and heads to Mars. So it's been a wonderful career for me. I feel fortunate that I got to meet John Kennedy. I feel fortunate that I got to spend some time in the Navy flying all the Navy airplanes. One of the beautiful part of my career is that as a Navy guy, I got to go to Air Force test pilot school. We exchange duty every year with a Navy guy going to Edwards and an Air Force person coming over here to Patuxent River for Navy test pilot training. And I was very fortunate to be the Navy guy that year that got to go to Edwards and fly all the Air Force airplanes during my test pilot training and come back to the Navy and fly all my Navy airplanes as a test pilot. All those things were, I kind of looked at them as stepping stones. And for you youngsters, here's a good word of advice. If you want to do something exciting one of these days, look at somebody that's already done it and try to emulate them. That means copycat them. Do what they did. I realized that when I was a young man that all the Navy, or most of the astronauts, majority came from the Navy. And all those guys were Navy test pilots and fighter pilots and carrier pilots. So if I wanted to be an astronaut, that was probably the best route to take with more odds of probably being selected to do that. So I joined the Navy, flew aircraft off of aircraft carriers 600 times. And the beautiful part of my Navy career is that my landings match my takeoffs. That's a good thing when you're a Navy pilot. So all my experience in the Navy and kind of a postgraduate school, test pilot school, all those, filling out all the blocks that the guys who came before me did. So when the time came in 1978 when NASA said we're looking for people to fly space shuttles, here I am. I'm your guy. So we went through about a year-and-a-half process of screening the final candidates, and I was blessed, as a good English word, to have been selected in that very first class of space shuttle astronauts. How much more could a little kid from West Virginia ask for? So I'm back to where I started. If it's something you want to do today, you youngsters, start thinking about it. Don't wait until the day before they're going to pick some astronauts to go to Mars. You keep in tune. You realize when they're going to do that, and you be ready when the day comes by getting the best education you possibly can and the best experience you possibly can, and take a look at the guys and the gals, the men and the women who've been there before, and kind of do what they did. And you never know. One of these days you might be that person to drive this thing. Isn't that beautiful? Might be the first person to drive this thing on Mars. Can't think of a better, more exciting career than to do that. Unfortunately, I probably might be a little bit too old by the time they take this thing to Mars and do it. So this was built, by the way, by the Kennedy Space Center Visitors Complex. There's no tax money into this thing. It all comes when you come down to visit us at Kennedy, which now is a 2-day thing. You can't see the Kennedy Space Center in one day. But when you pay your admission to come in, lots of that money went to pay for this vehicle that you see behind us. And for the folks going into the 5th grade, you can come in free this summer when you come down to Kennedy Space Center. So it's well worth a visit to come and visit, see this, and see all the other things that we've done in space over the last. First man went into space in 1961. So we've been launching men and women into space from around the world now for 55 years, with Alan Shepard being our first. First man in space was not an American. Anybody remember the first man in space? It was Yuri Gagarin from Russia. As part of my wonderful life, I've gotten to be president of all the astronauts and cosmonauts and met most of the folks that have flown into space now for the last 55 years. There are now 40 nations with astronauts and cosmonauts. I count 41 with West Virginia. And there's about 400 people in the last 55 years. So I'm very fortunate to be one of them and looking forward to some of you joining those ranks. I'm going to stop talking.
What a great story, don't you think?
Thank you.
Before we start taking some questions from our viewers here and online, what can you tell us about the purpose of this vehicle or a couple of its features?
Well, obviously, when we land on Mars, we want to have a way to move around and collect samples and study the planet itself. So this is in two pieces. It's connected right now, but this front portion with the four wheels will separate, and the people inside can drive away, drive around on Mars, collect lunar samples and soil and rocks and bring them back and dock. We redock with the laboratory, which is the back part, and they can transfer all that material into the laboratory and study it right here on this. And we're probably going to have 4 people that will lift off and go with this rover to the surface of Mars. So it's a wonderful machine. They'll have to have their ability to. People say, why do we want to spend all the money to go to Mars? My answer, simplistic answer, is that we have to be able to recycle and reuse everything we take with us. Nearly zero waste. It's called a closed loop ecological system. If we can do that, and we will, we have to. That one technology will more than doubly pay for whatever it costs to get to Mars and back, by allowing all of us in this audience and around this world who are tuned in to recycle and reuse everything. We have about 7 billion of us on the planet now, and we're using our natural resources at what we call an asymptotic rate. That means out of control. With 7 billion people dumping everything into the ground, all of our garbage, we can't do that forever, so we have to have the ability to recycle and to reuse everything, and we will find that. We will develop that through our space research that will allow us to go to Mars.
And one of the most important things to find on Mars would be water, a source of water, which would help sustain human life there on that planet. But they're also looking for resources that could be used to build a habitat or to provide for their electrical power system.
Exactly. We've got to do all those things. We're pretty sure that Mars had a lot of water at one time in her history. What happened to it? Why did it go away? They have a Grand Canyon, by the way, that's equivalent to from San Diego to New York. It's wider and deeper than our Grand Canyon, but it would stretch from coast to coast in our country. So it's a beautiful planet that had a lot of water at one time. So what happened to it? If we can find out what happened to it, maybe we can preclude that from ever happening here on Earth.
Well, let's start with a question from Facebook Live. Someone is writing in to say, how significant is international cooperation for the future of space travel?
I think it's very key that not just Americans and Russians and 2 or 3 countries are involved in this international exploration, which we're doing now. We have our International Space Station with, I think, probably 15 or 20 or 30 nations are either represented directly or have sent their citizenry up to visit space station. So international space is what it says. It's international. And I think that it would be a good thing for all Earthlings, all of us that live here on the planet, to be involved in this joint mission to Mars, when and whenever we do it.
And it really does make sense because space travel, space flight is expensive and more nations involved. Everybody has a stake in the outcome and nobody has to bear the cost alone.
Exactly.
Okay, another question from Facebook Live. Are the armed forces still the most sure path to becoming an astronaut?
It was initially when we picked our first 7, they were all military. All were experienced military fighter pilots, combat pilots. And when I was chosen, we had 15 pilots who were all military and 20 mission specialists who are mostly civilian. There were a spattering of military people in that civilian group. I'd say of the 35 of us, there were probably half and half military and civilian, roughly. The last class that we selected were half and half. We had 4 military and 4 civilian. I kind of foresee in the future that the military ranks will diminish and the civilian ranks will rise as we have less and less military influence in space.
There's certainly many ways to become qualified to be an
I
astronaut.
think that one of these days, even we'll carry it another 20 years into the future, we may not have pilots like myself, even in the military. We may be doing everything remotely through the control centers with the robotic airplanes and all those kinds of things. So mostly, I think in the next 20 or 30 years, the people that will fly spacecraft will be operators, technicians, people
engineers and scientists.
Right.
I think we have a question here in the museum.
How many times have you been in space?
I went to space one time for 9 days. We circle the Earth every 90 minutes in the space shuttle, so I went around 133 times. I was scheduled to be the commander of the mission that would have immediately followed the Challenger back in 1986. We were going to go up a month later. But with the Challenger tragedy and the unknown circumstances of what caused it and the almost 3 years it took us to recover, we canceled all the follow-on space shuttle flights and didn't launch again until 1988, late 88. So I spent the 3 years after the tragedy right here. Across the street, the NASA headquarters, where the old NASA building, and my office was on the top floor overlooking the Air and Space Museum, so I did spend maybe one evening over here at the Air and Space Museum during those 3 years in Washington.
NASA and the Air and Space Museum are good neighbors.
Yes.
Do we have another question here in the museum? There's a microphone over here. If you have a question, please step over to the microphone so we can hear you.
Do you think aliens are real?
Do I think aliens are real? If they're really aliens, then they're real, I guess. One of the things that you might not realize, but over the last, we launched the Hubble telescope, this wonderful thing that can see millions of light years away from Earth. And the Hubble telescope in the last several years has found what we would term Earth-like objects in this universe of ours. Maybe 300 or 400 of them look exactly like Earth, millions of light years from us. We haven't distinguished that people live there. But when you look at the odds of 400 of us 400 other planets that look like us, well, I think the odds are that maybe something lives on them. It might not look like us, might not be as nice looking as all of us are, right? But it's a good chance, I think, that there's life out there somewhere. It might not look like us, and it may. It may be a perfect image of us. But the odds are that not only are there, we can only see so far with the Hubble telescope. There are odds are that there might be thousands or millions of other Earths out there. So the probability of somebody maybe even resembling us, I think, is pretty large. I've never seen them. Some people have seen them. I haven't yet. But to discount the possibility that they're not, I can't definitively say there's no such thing. As a matter of fact, if you ever see one or meet an alien from another planet, be very kind to them, because they were smart enough to get here. So be kind.
All right, another online question from a Facebook follower. Do you think that government or private enterprise will be the first to send people to Mars?
I think it's going to be a government program, but who knows? That could all change in the next 10 or 20 years, but I would think that it's very difficult for a private entity to afford. If I'd have come to you in 1961 and said, would you finance launching Alan Shepard into space, a venture capital group or a private group, they probably would have said, well, when do I get my return back? I would have to have said, not sure we'll ever pay you back. And it's going to be $3 million, and you may get some money back one of these. Well, if they'd done that in 1961, they could have started getting their money back, because we're doing that. We're going to start launching people and these same kind of Alan Shepard rockets, and they're going to pay money, and they'll pay taxes, and they'll pay wages for people to operate those things. So in essence, people are starting to recoup the Alan Shepard money, but that was 55 years ago. A venture capitalist wouldn't have done that. I personally think that going to Mars is going to be prohibitively expensive for a private group to get into initially, but I don't know. that could all change in the next 10 or 20 years.
But private enterprise may well help figure out some of the ways.
And they may. As you all know, we now have private enterprise launching rockets from the Kennedy Space Center, so that's becoming more and more routine. But the complexity of going to Mars is, I think right now it's going to take some government involvement.
Okay, we have another question here in the museum.
Can I say it now? Where do they test the rover?
Where did they test the rover?
Where do we test this rover? This one was built in Florida at Cape Canaveral. And I guess we tested it there at Cape Canaveral and drove it around the Kennedy Space Center to make sure it would work before we brought it up here.
Well, it has these really interesting tires that look as if
The tires
they
are
would do well
built to,
on the
the
beach.
Martian soil has a lot of old dirt and sand and very fine particles. So we want this wheel, when it rolls through these particles, to drop all that sand out. So that's why you've got holes in the tread, so all the stuff that the wheels may collect would fall out every time it revolves. So, and they're light, so you want to minimize the weight. Obviously, it costs millions of dollars per kilogram to get things to Mars. So if I can take 10 kilograms off the weight of this vehicle, you can see how much less cost it would be and more other material you can take with you.
So when Captain McBride and I are not standing in the way, come up close and take a look at its features. This would be really cool to see on Cocoa Beach, don't you think? Riding up and down the sandy beach.
Somebody's asking if the rover has wheels, why don't you keep it on the back of the rover when getting samples? I don't know exactly what the answer to that question was. This is what all the people and all the knowledge and all the people who think that we're going to go to Mars and explore, this is what they think the concept vehicle will look like. It'll have wheels and it'll separate, and one little part will go back and come back and dock. That could all change. That could all change in the next 10 or 20 years, but we used the best knowledge that we had and forecast into the future and built you something we think it's going to look like.
Well, my understanding is that you could park the lab and then you could go drive around
Exactly,
and
it does
collect
come
samples
apart.
from farther away.
It's two pieces. You can drive the front part away and go around and research and pick up samples, come back and dock to the rear part again, and then transfer all that material into the laboratory. Once you're docked together, as you see it, all 4 crew members can live anywhere they want inside that vehicle. But there's a pressure wall between them. When you want to leave and go research Mars, you pressurize both of them, so when you separate, you don't lose pressure inside either one of them.
It's kind of like having a camper attached to your pickup truck, and you go to the campground and you leave the camper behind when you make a grocery run back in town.
Perfect analogy. That's a perfect analogy. This is a big camper, fancy camper that's going to land on Mars, and your pickup truck's in the front here, and all your sleeping quarters and things are in the back.
Okay, we'll take another Facebook question. What will we learn by exploring Mars that will help us here on Earth?
I don't know definitively, but one of the, lots of things we have to develop before we even go. As I mentioned, the ability to recycle and reuse. We have to upgrade and enhance our communications capabilities, being so far apart. So we have to, if we can only communicate at the speed of light. As far as we know, you can't go much faster than that. So all of our communications efforts will have to be directed toward being able to communicate at the speed of light. We also have to be able to recycle and reuse everything. Once we get to Mars, we have to have the ability to use Martian soil and material, probably inside this lab or another feature that we'll build to grow plants. If you saw the movie Martian, they were able to grow their plants, their vegetables, and their fruits. And we have to have that capability on Mars to grow and regrow some of our vegetables and things. So, I've told people we've developed 40,000 patented technologies in space research already. And before we can blast off and go to Mars in the next 1 or 2 decades, we're going to have to develop a lot more technologies that I'm not even thinking about today. And a lot of our NASA scientists are just touching on them. So it's going to be a very complex adventure or venture. And before we can actually do it, we've got to develop a lot of futuristic technologies that will further enhance the quality of everybody's life here on Earth.
Okay, we have time for one more question from here in the museum at the microphone.
How many years do you think you will use the rover in?
How many years do we think we'll use it? I'd just be stabbing in the dark and say 5 or 10 years. That'd be a good guess. you're going to have to worry about maintenance on this thing, and so we got a lot of things we got to develop. But I would guess a good guess would be 5 or 10 years that you could use it on Mars.
Well, there are no gas stations on Mars yet, so
No gas
it's going to
station,
have
no
to
power.
have its
You
own
can't
source
plug in
of
and
power.
get power and all those types of things. There's no 7-Eleven to stop in and grab some groceries.
Well, would you join me in thanking Captain McBride for being with us this
Thank you very
morning?
much. Have a wonderful day here at the Air and Space Museum, and come back. Come and see us down at Kennedy.
And would like to thank all of our visitors here in the museum, our visitors on Facebook, and we especially want to thank NASA's Kennedy Space Center for sending this fascinating rover up here for a couple of days. Captain McBride and I will be here in the area for a few more minutes, so if you weren't able to get your question answered during the program, come right up here to the fence, I'll call it, and we'll try our best to answer your questions. Thank you, everyone.
Thank you.